Hashim, this is the class rep, by the way, Hashim Rahma. I don't know why she's missing. Then we have Kamau Felista Njeri, Kimani Andrew Kamau, Maina Yan Miruri, Belenzi Mchendu, Muhaji Abdusalam, Mwadegu Shuma, then we have Stephen Otieno, sorry, Vekaria Devshi, Siganga Waundo, Zainab. Now, is any of you in this issues? In fact, I extended the deadline to 3rd last week. Is there any of you here today? Yes, Asiema. But I've seen Ochieng has entered. Who is here? You know, I'm trying to assist you. I'm not trying to reprimand you, but I'm trying to assist you because I could open up the system with some penalty. Yes, I can see a hand up. Who's that? Yes, Felin, you're here. Anybody else who is here? Yes, we have Maina Ian. You're also here. So those are 2 people. Is anybody else? All right. So I think you need to talk to me privately after this, so that we know what we can do about that. Now, I've taken a lot of time on that because I have now given a new assignment. I've given a new assignment. So if you go to your classroom, you go to you go to the where you have the practicals, Yeah, this practicum 2, this one here. I've just given it today. Now notice it is May 7th. Maybe the spelling is May 7th. It should be May 7th. May 7th. And if you look at it, let me just open it. Yeah. Here it is. So of course the part one we've already done, so you don't need to do that. But now part 2, which is question 2, 3, and 4, is what you need to work on. There is the OLAP that we did with you guys. So I haven't given you a specific data and a specific. So I've told you you go to Kaggle or other open source tools, and then you select the data of your. Now, question 3, you should also be able to answer, because we did this last week. I also showed you how you can do the coding from the sources, especially I showed you the Google. So we are now to tackle this question 4, which of course we shall be required to have new tools. Well, we can still use the same ones we've been having, like Power BI. I know we got introduced to Power BI, but we can we can still use that, but we also want to learn a few new tools like K9, and there's another one here called Orange. So we'll not do everything, but maybe we'll only do from A to F in terms of the assignment, that is, which means we shall have to demonstrate pattern mining capacity to do predictive analysis, cluster formation, rules mining, sequence discovery, and time series. Remember now, all these should be connected to the business question. You're not just doing it for the sake of doing machine learning. You're connecting it to the business. So once you do pattern mining, you say the pattern that you've mined, how does it relate to the business? How does it inform the business? So it's that kind of a stuff. Again, the ETL tools, you can just use the ones that you used last time or any other of your own selection. But please use ETL to do the transfer and the loading. So any question from the assignments? Remember, the deadline is May 7th. So you better start working immediately. Okay, now before we embark on the today's classes, we need to set time for our cut. Having the calendar here. So when would you like the cut to be?
Next week.
Some say next week. Maybe next week could be too soon because maybe I'll also cover issues that I'll be teaching today. Because I can't leave out the data mining part of it, which is critical. So maybe it could be the 23rd or 30th. Any of those dates. Remember, we are also moving towards the exam. Yes.
Can we do it in early May then?
I was proposing because the practicals we are doing them on 7th. That's the last day we are supposed to have handed in our practicals. So I don't know what's the best date. Because now if you say
No, sometime in May. Sometime in May is fine, sir.
But the trouble is that when you put it too far, guys don't revise. If you put it 14th of May, it is too close to the end of the term because the term is ending somewhere around that week, the following week. Then you start the exams around June 3rd or something like that. So it's a matter of negotiation.
Well, it's good because we'll also have revised everything. So, yes.
Okay, then let's then do it to 14th of May, which is more than 1 month away from now, which is very far. Is that agreeable? 14th of May?
Yes.
Okay, so let me just set it here. 14th of May. What is here now? That okay. I have another assignment there, but it's okay. I can. I'll set it there anyway. No problem. I'll set it here. So I'll say 14th of May. SC 328 CT. So of course I'll be sending we will do it physically in class, but that's okay. So we shall use that lab session to be it will be up to 3:45. It's just our issue time, 1 hour 45 minutes. We can do it 1.5 hours. But mine are usually long, you know that. I've taught you before. So let me add the, yeah, that's okay. Fine. So I think we have done that housekeeping issue. Then the other small housekeeping issue that I had is that I was looking at the register. Yes.
So will it be written or practical?
No, this will be written. It will be written.
Okay.
The practical bit I'm testing during these assignments, which of course there will be one on 7. But if you've submitted before, that's of course good. Yeah, so it will be paper-based. Yeah. So I was just looking at the register, which I'm also showing you on the screen. It seems the class rep has not filled it up. For 26, we have met. Did we meet on the 1st of April? I can't remember. I think we did meet, is it? Or when was it a holiday? No, the 1st was not a holiday.
First was a holiday.
1st was a holiday.
Yes.
Part of Easter.
Oh, this was part of Easter. Yeah, okay, it was Easter. So just right here, Easter. And there's no, and second we did it online, isn't it? Yeah, second we did it online, and today again is online. Tomorrow it will be practical. So I think you need to fill in today's second and the 26th. You need to fill it up so that we keep each other there. So again, the class reps are the ones who have got the rights to update you. So you better check it out whether the class rep has done the right thing for you. And I mean I think there are 4 class reps. There's Rahma. Who are the others? I think you know them. Amina, yes.
Gloria and Gregory.
Oh, Gloria and Gregory. All right, fine. So you'll do that. All right, we've taken a whole 15 minutes of that housekeeping matter, but it's okay. So let's move to today's notes. As I said, we want to look at these data mining. And as you know, it's not a very new thing, because if you've done machine learning, then we're just building up on that knowledge that you've been doing. But here you see that I've added more material on especially pre-processing. Yeah, there's a bit of data on pre-processing, data pre-processing. There is also normalization. Yeah, and there's a whole book on data mining. Now, I like this book because it goes beyond data mining in terms of data. It goes to text mining, text, and also multimedia mining. So the book covers much more wider. And there are 2 books. So let me just start it off. You can also open it from your end so that we can move together. It's taking a sweet time to open.
Excuse me, sir. I have a question.
Yes.
Yes. Is the normalization here just the same as database normalization, or it's a different thing?
Oh, it's very different. Very different. The database normalization, is about reducing the redundancy, isn't it?
Yes.
but this one is about something called regularization. Now, this normalization in data mining, it will involve things like the scaling. Of course, I'll be getting there within as we talk. That's good if you asked in advance. But it will really talk about things like the scale, and even from the very basics. Like, for example, if you have some data and you wanted to put it in categories, so you want to put that data into categories. So there's moving from nominal to categorical data. Categories would mean maybe like 1, 2, 3, 4, 5, so that they're easy to do machine learning on. Scaling would mean something like maybe you are dealing with something like salary. One of the attributes is salary, for example, which has a very huge range from, let's say, 10,000 to have 1 million. And maybe the other one would be gender, which can only vary between 1 and 2. So you need to put them in the same scale so that things can work together. But we shall look at the details of that and some of the algorithms that you can use to do quick normalization. So we shall go, of course, through the theory as we normally do. We go through the theory, and then we can look at some few other things. Okay, so we are talking of this data mining. People also call it knowledge discovery in databases, and very soon you shall also see some other terms. Now, under my notes here, what we want to look at is the introduction to that concept of data mining. What are the motivations? What are the applications for this data mining? Then, how is the KDD process? Knowledge discovery in databases or data mining. How is it? So the kind of data you handle, the steps involved in this, some of the tasks you can do. Now, remember, some of these tasks you've covered them in when you're dealing with business introduction, the introductory part of the business, where you talked of basket analysis. That when you're dealing with that, the business question. We talked of a few things you could, the tasks you could do, like profiling. Sorry. So that's when you are creating profiles from customer data, and all that we talked in that first chapter there. So now you connect that with what we are dealing with today. Of course, there are the methods. This might involve, the specific methods that you use for different parts of the KDD process, including combination of the data selection, attribute selection. What else do you think we'll be selecting? So the first thing is, of course, data, because you need to know what data you want to deal with. Then once you know the tables that you're dealing with, then how do you create the views? How do you create one or several tables that you can deal with? So of course we have dealt with that part, because that is where we dealt with the warehouse, where we say the star. So are you talking of the star? Are you talking of the galaxy or whatever? Then once you do that, you need to know which are the critical attributes. So that will be something to do with the critical components analysis, or something called CPA. If you want to seem educated, and then people will say feature engineering. Feature engineering. Feature engineering is all about selecting the features, isn't it? So how you target the features and how you test them to see that they are really the ones that are giving you the best results. So once you do that, then of course you know that you need to select an algorithm. Are you going to use neural networks? Are you going to use SVM? Are you going to use let's call it a decision tree mining. Are you going to use Bayes networks and Bayes theorem? So there are all these array of algorithms, including those ones from what do you call it? The reinforcement learning, reinforcement learning methods. And then from there, of course, we have the rules. Who does what within the KDD process? If they're the business people, if they're the database people, who does what? So that is the KDD process that we should deal with there. Then lastly, we should deal with the software tools. We shall also deal with some ethics and also some of the difficulties that you might encounter. And finally, the general methodology. You can use the waterfall, but the one that's usually preferred is the CRISP DM. We shall look at it briefly. So most of these are just written notes, so I'll move very fast because you can always look at them. But this definition, we came across it the first time, but we want to repeat it again, that when you're dealing with data mining, also referred to as knowledge discovery in databases, we are looking for patterns, or we are looking for new information. And how do you know that the information you've gotten qualifies to become a data mining product? So one of the things we talked about is that the pattern you've discovered should be non-trivial. So it should be a major thing, not just like getting a mean or a standard deviation, those ones you did in statistics, those small things. So it should be a big pattern or a big thing that you're dealing with. We shall look at the categories of the big things. Then we also, and the second measure, for knowing that it qualifies to become a product of data mining is that it should be implicit. Implicit means that it was not visible from the hidden eye, isn't it? Of course, the opposite of it is explicit. So you're dealing with implicit knowledge here. Then the third one is that it must be previously unknown. So that's why it's a discovery. Otherwise, it will not be a knowledge discovery if people already knew it. It will not be discovery. And it will be potentially useful. Useful to who? Useful to business people. And it is useful in terms of advancing the business requirements. So businesses, of course, have got very different requirements. It could be in terms of their profits, so they want to maximize. It could be in terms of efficiency, they want to maximize. It would be in terms of maybe satisfaction levels from customers or suppliers or whoever it is, or even the employees. So satisfaction levels from all the three groups. Again, that is, and all these are things that become useful, or if it is in terms of a losses, then you want to minimize them. So these are valid business objectives that should connect to your data mining knowledge that you've just discovered. So on that note, when we'll be dealing with question 4 practically, remember the one I showed you a few minutes ago, question 4 on the assignment, you will be expected to show that the knowledge that you have discovered with your pattern, with your machine learning method, that knowledge is non-trivial. That knowledge is implicit, so it was not clearly visible with the naked eyes. It was previously unknown, and that it is potentially useful to the business fraternity. So you'll be expected to show those 4 things from that assignment. Now, typically, because we are dealing with the data from data warehouses, we shall be looking at large patterns. I mean large databases. So that if you're looking at a time series as a pattern, then you can have a wide range. If you are looking at occurrences and the patterns in which they occur, so you know that's another pattern. That would be another pattern that you would want to show. If we are showing clusters, there are clusters that are consistent within a long period of time, and the classes and so on. So all that is very useful information. Now, the second point is that there are various names that are normally used to be associated with this data mining. Already I've told you knowledge discovery from database, one of them, also called KDD. But we also have knowledge extraction. You have pattern analysis, data archaeology, data dredging, information harvesting, and business intelligence. But of course, you know, business intelligence for now, we've defined it to specifically mean looking at the past historical data and reporting on it, maybe through OLAP and all that. But more specifically, data mining would be within the class of what? Analytics. So data mining would be more in analytics. But this time, some people, you confuse them and you'll hear people using them. But strictly speaking, business intelligence is not data mining. Actually, more closely related to data mining is actually what? Is analytics, because it looks at the analysis of these patterns and so on. So if, for example, you do some SQL queries, simple ones, that will not be query processing. Well, that will not be data mining, it will be query processing. And you notice that when you are dealing with SQL, mainly we talked of OLAP. That's when we had a lot of inner join and outer join queries. But that's actually business intelligence. It's not this analytics thing. It's not data mining. Now, when you deal with expert systems, again, that's not a data mining. And when you deal with the small statistical programs like the ones I mentioned of mean, mode, median, that is not. But if you start dealing with things like ANOVA, and who remembers what ANOVA is? It's also part of statistics. What is ANOVA? ANOVA. Who can remember what was ANOVA?
A significance test.
On significance test. Yes, you can do that because ANOVA stands for analysis of variances. Analysis of variances. So usually you apply it mainly when you want to check on variances. So you remember from your statistics what a variance? A variance is simply a deviation, a deviation from the pattern, from the norm. So you have some two bands, upper and lower, then you look at how far the variance is getting out. But now ANOVA really goes, it's a whole statistical subject in its own. And I would like to invite you to even Google a little bit on ANOVA. Maybe I can even check it here as we are together. Let me just check with you here. So if you just Google ANOVA, There's even ANOVA test, ANOVA whatever. So here it says, I hope you can see whatever I'm showing. Yes, you can see it. It says that analysis of variance, or ANOVA, is a statistical method that separates observed variance data into different components to use for additional tests. A one-way ANOVA is used for 3 or more groups of data to gain information about the relationship between the dependent and the independent variables. So there's much more you can read on your own later. But ANOVA is a statistical formula used to compare variances across the means of different groups. A range of scenarios use it to determine if there is any difference between the means of the groups. So anyway, you can even have a look at this complete guide. Complete guide to statistical. So what I'm trying, the point I was projecting is that now when you start going to deep analysis like ANOVA, then now, am I still presenting? Yeah, I think I am. So I can simply go back to my slides. You now start moving now towards data mining. So that ANOVA could be categorized as part of data mining. Yeah, it's presenting. Yes. Now the motivations. Now one thing you know is that there's a lot of data available in the industry today. It could be transactional, it could be medical, it could be time series data, it could be text data, it could be documents, it could be from the internet, it could be from the scientific engineering, remote sensing data. All that is part of data. So like when you are dealing with the text is becoming a very important part of data mining, but we call it text mining. You'll hear things like sentiment analysis there. Sentiment analysis, you'll find them there. Another one you'll find is called, so sentiment is about what, by the way? Sentiment, like for example, if you had data, comments from people reviews, so they have bought a product. So they are reviewing on that product. Let's say you bought a phone. So people are reviewing on that phone. So they'll be writing all sorts of sentiments there. They'll be saying this product is good because of ABCD. This product is bad because of ABCD, etc. So you can be able to separate good sentiments from negative sentiments. So positive and negative sentiments, and sometimes neutral sentiments. So it's called sentiment analysis. Then a manager at the back there can go and look at why are people saying this product is bad. Then they can try to improve on it. Or why are they saying it's good? Then they can improve on it. But text mining can also involve other things. There's one called argument mining. Now you heard me right, argument mining. So what's an argument? You know, in debate, you have let's say you have two opinions. I don't know, those debates you used to do in school. Like a boy is more useful than a girl, or a girl is more useful than a boy. You know, there are those two opinions. But then there are the arguments behind those opinions. Isn't it? They are the arguments, the points for and against that opinion. So really, argument mining goes beyond sentiment, and now it looks it looks at what are the reasons people are saying whatever they were saying. So sentiment analysis would just say, okay, this is good, this is bad. Then the human being is going to do whatever he wants to with that information. But then argument mining will go and filter out. It will get out the reasons. So maybe they were saying it fails, it hangs, or maybe the internet is inapoteza networks yote hiyo simu so is bad, or whatever reasons they gave. So this text mining is very, very important. We look at it a little bit so that you can also be comfortable. And another one is multimedia. So multimedia, before you go to multimedia, there's image analysis. I don't know whether it's here. Medical, yeah, medical data. Okay, this could be data. Yeah, but there is a image. So you can also mine from images. You can mine from images. So for information, like for example, if I had so many data, like for example, Google uses it to mine your images. So if you, for example, Google Lawrence Muchemi on the internet, probably they will go and look for one photograph of mine where it has a name. So it is associated with that name. So once it's associated with it, then it can mine all the others. Let me see whether I can be able to show that practically. If, for example, this is what I'm talking about. So I have escaped. I'm now on the internet. Let's say if you Google something like my name. So if you, first of all, Google Lawrence, it will bring Lawrence of Arabia. Another Lawrence is here. But if you now go to Muchemi, let's see what it thinks of me. If I hit on that one, now you see, here it has, I'm working at the University of Nairobi. It goes to my Google Scholar. Then it brings some guys here. So it thinks that must be me. Probably it got the first two guys right. But for some reason, it linked me with this character, whom I don't know who he is. Oh, there's another one here. I don't know where it got this from. But anyway, the point I'm trying to say is that it associates my face, which could have been this one from the university. It associated it with this, and with this one, which it has captured correctly. It also thinks I look like KJ. This KJ, yeah? This KJ, it thinks that I'm KJ. I don't know why. Whatever. So that is part of text mining. So where it goes and figures out who Lawrence Muchemi could be. Yeah, I can see guys are excited there. All right, but let's go back to the notes. Yeah, these notes now. Data mining, yeah. So there's a lot of mining that has been done, and it's all very interesting. But even Google has applied some very sophisticated algorithms to mine those images. Like if you give it an image, there's a product like that one. I can't remember the name. It's not Chrome. It's called what now? I was remembering that name, but it has disappeared.
I think Google Lens.
Google what?
Lens.
Google Lens. Yes, that could be Google Lens. Yes, correct. Yeah, whereby you just give it an image, then it go and look for all the other guys who look like that image. Now, those are very interesting applications of image mining. So I've given you examples of 3 things. So there is image mining, which we've just finished with. There's text mining, we're talking of sentiment analysis and it connects to business. And of course, we have the rest of the data mining, which is these transactions and all these where we're trying to do things. All right, so apart from evidence of data, we also have competitive focus. And let me tell you something here. You know, some of these I've not put it on the notes, but I'll just tell you. Those of you who come from business community, maybe your father is a business person, or you are involved with a business. I know all of you will be involved in a business within the next 1 year or so. But business is war. Business is war. The only difference between business and a battle or a war is that one is a battle of intelligence, as well as it's not hot war, it's not using guns, it's about winning customers to make more money and this kind of thing. So what happens is that every business must be able to do a few strategic things, which is now done by this data mining thing. And that's what we are calling competitive focus. That second bullet is what I'm trying to expound on. There is what we call locking your customers. So you focus on your customers and you lock them. So if you have a relative or you happen to work with a business, the customers that you have, you don't want them to go away. So you lock them. The other one is that the suppliers that you have, the suppliers, you want them to be happy with you or to minimize the cost of delivering the goods to you. So you want to have a competitive edge over your suppliers or on your, so it means that maybe you'll be getting your raw products at a far much cheaper cost than maybe your competitors. So those are already 2 strategies, this competitive focus. So one is on customers, the other one is on suppliers. The other one is strategies to deal with the substitutes. So substitutes, you know, some guys can say, instead of eating, let me not use eating. No, substitute, yeah. So substitute would mean that instead of eating chicken, what else can you eat instead of chicken? You can eat beef, isn't it? So these 2 are not really in the same market. Chicken market and beef market is not really the same market, but somehow they are affecting each other because one is a substitute of the other one. So you must know how to deal with substitutes. So you'll see a lot of propaganda going around, maybe white meat versus red meat. So most of those are propagandas that people are trying to, you know, to sell their products and say the other one is not good because of this and the other one. So that's substitute. Then the other one is you deal with the competitors. So there are those that are direct competitors. Like if you're in the business of selling chicken, then there's another guy who opens a kiosk next door. He's also selling chicken. That's a direct competitor. So I've given you already 4 strategies, competitive focus. There are 5, I've forgotten the other 5th one, but if you Google them, you'll get them. But if you didn't even remember those 4, you'll know how you use knowledge. These data mining to be able to focus on your competition. Then you have inexpensive and powerful computing power. Then you have a strong theoretical and mathematical foundations. Like you guys, I'm meant to understand. You do a lot of maths. I don't whether you are strong or not. I don't know. But you need to be very strong in maths because you'll find that you need them in this class. Also theory. Things like machine learning, statistics, database management, visualization, all these you need to be very good at. So there's a mantra there that we are drowning in data, but starving for knowledge. We are drowning in data, but starving for knowledge. Now the applications, we dealt with these the first lesson, but we can just mention them here again. Marketing, we saw segmentation, customer targeting, and so on. Finance, we had things like investment support, portfolio management. Banking and insurance, I expect credit and policy approvals. And all the security, we have fraud detection, intrusion detection. Science and medicine, you can apply it in hypothesis discovery, prediction, classification, diagnosis. Then manufacturing, we have process modeling, quality control, resource allocation. Engineering, we have simulation and analysis. Pattern recognition, signal processing. And internet, we have things like web marketing and smart search engines. So these are a few just indicative application areas in which you can apply your data mining. Now here are some examples of successful stories. Those ones you can read later. But then related technologies. Luckily, we have already seen this. We now know that OLAP is not part of data mining, but it is related. So we now know it, how you go about that. We also know data warehousing is also related, but not the same, and also visualization. Visualization, we saw this last week, luckily. Methods, you guys did last semester, you did machine learning, so you know these methods very well. Decision tree learning, artificial neural networks with all its variants. You know this back propagation. What else do you know? You know things like CNN. You know CNN, convolutional neural networks. CNN.
Yeah.
Yes, that is part also of artificial neural networks. And there are others like RNN, recurrent neural networks, etc. There's others like instant-based learning. This would be things like the ones you did with K-means. There was a K-means clustering, etc. There is evolutionary algorithms. Did you deal with any of them? Evolutionary algorithms. Did you deal with any of them?
Yes.
Yes, genetic algorithm. Yes, so if you dealt with that, that would be good. So you should be able to know how, for example, you can, like the things we are dealing with a few minutes ago of comparing images. You can use the evolutionary algorithms to compare images. When I used to teach that class of machine learning, I used to give my students a task of taking an image, subdividing it into chromosomes. So chromosomes would be things like the eyes, the nose, the mouth, the hair, and all that. So within the chromosome, you'd have the specific genes. So the genes would be things like the shape of the eye, the color of the eye, the relative sizes, and all that. So those would be the genes defining that eye. And then now we populate our database with many, many faces. And then we use evolutionary algorithms when you're targeting a certain end image that we want to have the best match for that image. Let's say you're looking for a thief. So we can be able to do that. So this is a very interesting topic, evolutionary algorithm. Okay, you have SVMs and you have Bayesian networks, which I think you all covered. Then statistics is very wide. I've just given you ANOVA is one of them. There are others that you'll get inside there. And I've left others like regression. Regression might not be statistics, but it might be in algebra, but it could be part of it. Now, this other one here, I think I'm just repeating. So this one I should even remove it. But I was just saying knowledge is equal to a pattern and the relationships. In other words, once you say you have a pattern, you must be able to describe it. You cannot just say this is a pattern, but you don't know how to describe it. Even if it is descriptively, using words, you describe it descriptively. You describe, but you can define the pattern. Data mining task prediction. There's also descriptive methods. Prediction, of course, you use some variables to predict an unknown or a future value of another variable. Then descriptive methods, you can find some human interpretable patterns that describe the data. Of course, from the tools perspective, or from the algorithms perspective, if you're dealing with the predictive methods, you can have examples like classification, regression, deviation, detection, etc. And if you have descriptive methods, if you find clusters, then you can use some descriptive words to describe those clusters. You can use association discoveries. So that's another example where you can have description methods. Then you also have sequential pattern discovery. Now let's quickly look at the process. It's very simple because it mirrors the machine learning process. But remember here we are starting with the ERPs, these data sources. These data sources that we discussed last time. We had the ERPs. We had the MISs. We had the OLTPSs. And all that concussion, it forms, and even external databases, remember. External databases, all that forms your data sources. An external data source example would be like the exchange rate. If you want to know what was the exchange rate last year at this time, that is April 8 last year, all you need to do is look for the central bank data at that time, and then you can get what the value was. So you can also plug in external data sources. I hope that point is clear. So when you're dealing with data mining, it's not only the ones that are in the warehouse per se, but you can also combine it with other extra sources, like external sources. Once you do that, as usual, you go through a staging process. I've done this process likely, you know it. You do an ETL, then you create your warehouse. Now, 20 guys at the beginning of the lesson, I said they have not yet submitted their work. So I don't know whether they know how to do that ETL thing or not. Now, if you came late, I said you see me privately. We discuss how we can assist you. All right, so you create your warehouse. And up to there, we know how we go about it. Now from there is now when we start now our data mining. Now our data mining will mean we do feature engineering. Remember I described this earlier on, feature engineering. But before the feature, you could select the data the exact data that you need. That's what we mean here by selection of the data, okay? Selection of the data. So you select which data you want to use. Then now you do pre-processing, it's a big business. I'm going to show you later on. It's a big business. If it is for text, there's a way you do pre-processing for text. If it's the ordinary data, there's a way you normally deal with it. If it is image, there's a way you deal with it. And if it's multimedia, which means that you have, of course, a multimedia means that you have a JPEG or an MPEG, which you can convert into stills, by having some photos, stills, that's what you call stills. Maybe sampled over a specified time interval. So you convert that MPEG into an image. Then you can apply the normal image processing methods. So there's a whole business of pre-processing of either all those data that I've talked about. So the ordinary data, text data, image data, and the multimedia data. So those 4 data types. So you pre-process, of course, maybe by removing unwanted data. Another thing I mentioned at the beginning of the lesson was normalizing, which I said I'll talk about briefly. And then once you do that on normalizing and everything, then of course you must also do what you call feature engineering. Sorry, maybe I think I'm skipping some things. So let me repeat it. So you've selected the data. Okay. Once you select the data, you say now these are the tables you want to apply. Then now you say these are the most, you do pre-processing by removing unwanted data, and then you normalize and everything. Now, after that, you now select, you do now feature engineering, where you now select the most important features. So features engineering is the last, you do it there. Once now you have the data with the best features, features just means columns. The best columns, that gives you the best results. You can now apply what you are taught last semester, that's machine learning, where you apply the patterns, or rather where you apply the machine learning algorithms. And the end product is what you call a model. So remember, a model could be a mathematical model. It could be, for example, a neural network model where you know the number of hidden layers, and you also know the learning rates, and you also know, what else do you want to know there? The threshold values. And you can also select your activation functions. So it's already a predefined model. A predefined model will be having those features maybe determined already practically or through experiments. You can determine the model of choice. Now, once you do that, once you have the model, you can apply it now on new data, and you can discover your patterns. And lastly, on the last point there of knowledge, for you to know that it is a proper knowledge, how do you evaluate it? You use the 4 things that we talked about, and you preferably work with the business people. So let them interpret it for you, and they should tell you and evaluate it and tell you whether it is new, it was implicit, it was useful, and all that, the 4 things we talked about earlier. So if it is, then you know that you've completed your knowledge. But if they argue that it is not, then you need to go back to the data sources and do the whole thing again. So any question on this process? Because the rest of the notes explain this. Anything you'd like me to explain further? Okay. So I said the rest of the notes just explain this. Like, for example, develop an understanding of application domain. Remember this way we're talking about the business question. In our notes, we call it a business question. So you develop an understanding of the application domain and the relevant prior knowledge and the goals of the end user. Then you consolidate the data. You create target data. You do data cleaning and pre-processing, and then you transform the data to find the useful features. So this is just what I've explained there. Then you select the mining task. You choose the data to be mined, that's the algorithm, the data mining tool to be used. Then you interpret the mining tools and relationships, and then consolidate the knowledge. Then the steps in the KDD process again is sort of repeated, but I will get back to the support notes that we have. So learning the application domain. So again, they are repeated. So I don't think I need to go through all of them again. But the importance of this slide here was to show you that data cleaning might take a lot of your time. Data cleaning and pre-processing, that involves selection of the features and so on. Takes you about 60% of the time. So you clean the data, you normalize it, you do pre-process, feature selection and so on. Then you also have to be able to find useful features. The features, we remember I said, is about the attributes. The dimensionality of variable reduction. So again, you want to be able to reduce the number of the features. So if there are so many, in a practical case, you might have like 100 features. So you want to reduce them to maybe 15 or less. So you need to reduce the dimensions or the number of those features. Another thing, I put a stroke there, variable reduction. Each of those features has got the variables it carries. Let me say the first feature is gender. Gender, for example. Gender, does it have variables? The variables are male, female, or is there another one they're adding nowadays? Undefined. I don't know what that would mean, but undefined gender. So you try to reduce those variables like the female, male, undefined. Then you also try to show that, or you make sure that things that do not vary, things that do not vary, there's a way you can represent them. Things that don't vary. Like, for example, I'm looking at, I don't know. I don't have a very good example here, but there are variables that rarely vary. Like, for example, you are dealing with the data of 2024 only. 2024. So every data that you find there has got a 2024 at the end. So the component year is invariant because it's 2024. It doesn't change. So you need to know how you can represent that. Maybe you can say it's like a primary variable because it's one of the main features about that data. Then, of course, you can choose the functions that we've talked about the whole day. Summarization, you have classification, you have regression, you have association, you have clustering. And many others we have looked at. Then you do data mining, pattern evaluation, etc. So before we go to this, I wanted us to have a look at what I have as extra notes, which you need to read. Now, data preprocessing. Let me start it with it from Gigs for Gigs. Gigs for Gigs is very interesting. Because it's simple for everybody to understand. I don't know whether that will open. But in your notes, if it doesn't open, just use the PDF. I even don't know why I started with this one. It should be the PDF one. Seems to be opening. It has opened, although I was saying it might not open. It has opened on my notes. But this is what Gigs for Gigs says. I hope you can see my screen. This is what Gigs for Gigs says about data preprocessing. And you need also to understand these simple tasks. This is that data preprocessing is a data mining technique which is used for to transform the raw data in a useful and efficient format. Now, it has got three components according to Gigs for Gigs. The first one is data cleaning. And this would mean that you need to deal with things like missing values. And some of the ways in which you can handle these missing values would mean, these are just examples of how you can handle it. You can ignore the tuples. You can fill the missing values manually or by means of a most probable value. So that's another second way of filling missing values. And so those are two ways. So another data cleaning method is noise reduction. So there are three techniques for doing that. There's one called binning method. There's the regression method and there's clustering method. Now these methods are explained down there, so you don't have to worry. Then there is a data transformation. You have the normalization, attribute selection, which is also called feature engineering. There is discretization, meaning that you want discrete data. Discrete data. It could be in a text form, but you want to like male, female. So you want 1, 2, like that. Then the last one is a concept hierarchy generation. They are explained down there. Then the last arm of this data preprocessing is data reduction. So you can have things like a data cube aggregation. It means that, for example, if you have, like we had our data for data warehouse, you can aggregate the data in a process we are calling moving to the course levels. And the example you give is the year. So you can move from the month. Sorry, you can move from the day to the week, to the month, to the quarter, to the year. So that one, you're using a data cube to aggregate. You can also reduce the data by reducing the subset of the selected attributes. I think I had mentioned that earlier. That you just reduce the number of the subset selected, and there are some techniques you use to be able to know how to select. There's attribute selection algorithms for that. It's explained again down there. Then there's the numerosity reduction and the dimensionality reduction. So if you go quickly down, I'll just peruse it because most of you can read. All of you can actually read. Steps involved in data processing, data cleaning, missing data. So they have explained how you can ignore tuples, how you can fill the missing values, and the noisy data removal. So the noise data removal, they've said you can use the binning method. The binning method. And this method works on sorted data. So you sort the data in order to smooth it. The whole data is divided into segments of equal size. And then various methods are performed to complete the task. So each segment is handled separately. One can replace all data in a segment by its mean or boundary values can be used to complete the task. So binning, I think you've understood it. You have a whole stack. Then you sort it out. Then once you stack it out, then you segment it. You put it into segments. Let's say it was like 1,000 data. You subdivide it into 10 segments. So those 10 segments, now you just represent it either by the mean of those segments or by the boundaries of those segments. And you can see a whole 1,000 data has been reduced to 10 data. So that is one method that I've tried. There's regression. They're saying here that here data can be made smooth by fitting it to a regression function. The regression used may be linear. That is, it's having one independent variable. That is y is equal to x, if you want to know. Y is equal to x, or y is equal to mx plus c, isn't it? Or you could also have multiple variables, like y is equal to x plus z, something like that. Those are two variables. Then there's the clustering, and this approach groups the similar data in a cluster. The outliers may be undetected, or it may fall outside the clusters. So what I'm expecting from you, of course, is to read a little bit more on these. Don't just read these notes and be happy. You should go and find out binning method algorithms. So you come up with those algorithms. Regression method algorithms, clustering method algorithms for this particular process. Now, data transformation, we have talked about normalization. It is done in order to scale the data values in a specified range. So I talked about this scaling. For example, you can move the scale from -0 to 1, or from 0 to 1. But there are some algorithms for that, and maybe I have a slide or so about that. I'll show you. And then there's attribute selection. So in this strategy, new attributes are constructed from the given set of attributes to help the mining process. Discretization, this is done to replace the raw values of numeric attributes by interval levels, etc. And then there is a concept hierarchy generation. Here, attributes are converted from level to higher level in the form of a hierarchy. And we saw this like when you are dealing with the city and country, location, that is. That is a hierarchy generation for location. We have data reduction. We saw the cubing, data cube. We also saw attribute subset selection. So the highly relevant attributes should be used. Rest all can be discarded. For performing attribute selection, one can use level of significance and P negative value of the attribute. The attribute having P negative value greater than the significance level can be discarded. So there's this thing called significance level. You can, if you're not familiar with it in statistics, maybe you did not cover that. Just Google this significance level, and you'll be able to see how it is done statistically. This is part of statistics. That's why I said mathematics should be your friend. Because now if you don't know this P value, you might want to go back to your to your class, or you can just Google it up here. Then numerosity value, this enable to store the model of data instead of the whole data. For example, regression models. So it's just summarizing data through like a formula if you can. Then there's dimensionality reduction. There's something here called the PCA. I think this, please go and look at this also. Principal component analysis. That this reduction or this reduces the size of data by encoding mechanism. It can be lossy or lossless. If after reconstruction from compressed data, original data can be retrieved. Such reduction are called lossless reduction, else is called lossy reduction. The two effective methods of dimensionality reduction are wavelet transformations and the principal component analysis. Now, but this is a very important concept in computer science, because think of JPEG. JPEG. You know, that is a dimensionality reduction of an image. Why? Because if I take your image, how many pixels would it be? We take just an ordinary photo. There will be so many pixels. But then I can compress it using a JPEG. And when you look at that image, it will tell it is still you. Okay? So what they are saying here, if you compress and then you decompress, and then there's loss, then that's what they are calling loss reduction. But if you compress and then decompress into the original size, then that becomes lossless if nothing got lost, if you can still recognize the same image. And that was one of the successes of MPEG and JPEG, because it was so lossless, and you can compress it as many times without losing much thing. So please go and look at these two principles here, wavelet and the principal component analysis. So that was Gigs for Gigs. Of course, you can read more about this difference between data mining and text mining. All these are nice links you can read. Data mining and web mining, types of sources of data in mining, data normalization in mining. All these, they are interesting reads, which you can see they are not hard to understand. But please do emphasize on the algorithms, because that's important. Now, the other one is this normalization by these Google developers. Let me open it. Before I direct you to the book. It's taking a sweet time to open. It has opened now. But this was an article I got from who? some guys who are using a Google development. There's a lady, but I can't see her name here. Yeah, so it's a nice read, but I wish we can get the original article. This one of Google developers. But nevertheless, let's have a look at it. Please go and look at the original article. It's usually very nice. Normalization, the goal of normalization is to transform features to be of similar scale. This improves the performance and training stability of the model. But I wanted the original because they have done some experiments and the whatever here are missing. But here is the website. If you go, scroll to the bottom, I think you'll get the this site. Let's see whether I can be able to do that. Let me try to open it. Oh, it doesn't want to copy things here. Ah, okay. It needs me to convert it into text, which I don't feel like. But what is it saying here? Highlight, I don't know. Okay, I think we might not have get the whole time, but it's about Google developers. About Google developer, let's say, of course, you guys can join here through an account, maybe the student club or something. So you can see data normalization. I just want you to give me something here. Maybe this one will. There's one for Stackflow there. Let's see what they have here. Yeah, here it is. Here it is. Here it is. So if you want, let me copy this for you. So look at your chart. Just click on that link. I'll answer those questions that you asked there. I can see you had asked questions on the chat. But the point here we were trying to make is on normalization. So I was just trying to emphasize that normalization techniques at a glance, there are about 4 common known methods. Are you able to open?
Yes.
Very good. So there are about 4 known methods of normalization. And there's scaling to arrange, clipping, log scaling, and Z-score. So please, what do you call it? Store that page because you need to read it later very well. Now here they are showing you, the following charts show the effect of each normalization technique on distribution of the raw feature. On the left, The charts are based on data set from 1985 World's Automotive Yearbook. That is that book there. So the price, if you do this is the raw features. This is the raw features. Then I think if you make it bigger, you'll see this is scaling to arrange. This is clipping, and this is a log scaling, and this is Z scaling. Now, the whole idea, because you might not know from this very quickly, the whole idea is that as you run through the algorithms, usually there are libraries that are already inbuilt within, let's say, Python. You can select these algorithms. So you can say, I want to use scaling to arrange, or you want to use clipping, or you want to use log scaling, or you want to use the Z-score. Then you can see the effect on accuracy. So you select the one that gives you the best accuracy. Here, of course, they have tried to explain to those who maybe whose mathematics is lacking a little bit. They're saying now what is scaling to arrange. Of course, that is, you just take the value. So the new value is equal to the old value minus the minimum value divided by the maximum value minus the minimum value. So it's just dividing by the range. So you take the value, remove from the smallest value, then divide by the range. So that's what we're calling scaling to arrange. Now, this is mathematics, by the way, now not too much computer science here. Now there's feature clipping, where now we are trying to remove even the outliers. So if your data set contains outliers, feature clipping, if your data set contains extreme outliers, you might try feature clipping, which caps off feature values above or below a certain value to fixed value. So for example, you could clip all temperature values above 40 to exactly 40. So if you select that formula or that algorithm, this is what it will do for you. Now for log scaling computes the log of your values to compress a wide range of narrow range. All right, so you are compressing them to a narrow range. You can see like this range now is from 0 to what? What is this number? Was it that 6,000? Whatever, 3,600 or something like that. But it has been reduced to range between 0 and 8. And then finally the Z value. So the Z score is a variation of scaling that represents the number of standard deviations away from the mean. So you include here the standard deviation thing. So you would use Z score to ensure your feature distributions have mean is equal to 0 and the standard is equal to 1. It's useful when there are few outliers, but not so extreme that you need to clip. So in a typical exam question, for example, I would ask you to explain, for example, the formula behind, say, Z score or the log scaling or the clipping method, which is basically on this table here. Then I would also ask you, you outline the conditions that would be best to use clipping over log scaling. So I would expect you to, to remember this, because you have also done them practically. Okay, you have also done them practically, so that things can be okay. So I think we've done a lot on that, but let me just mention this again. That was on normalization. There is a whole book on our notes now. I'm back to the notes. There's a whole book here called Data Mining, a book introduction to KDD data mining by Hotu Bao. That must be a guy from Japan. And you can open that. Now, this book is very important because it gives you another perspective of everything that we've learned. So it's just another perspective. So it gives you all the things we've done, what's KDD process and all that. It gives you things to do with pre-processing, the ones we've just dealt with, about data quality, data transformations, missing data reduction. It also talks about data mining with the decision trees. So now this is very important. When do you deal with the data mining with the decision trees? Data mining with the association rules. So they have just given examples here. Data mining with the clusters, data mining with the neural networks, evaluation. Where is that? Yeah, evaluation and use of discovered knowledge. So here you will see here they're giving it a different dimension. They are giving on an error rate, resampling techniques, and all that. So I think you can also have a look at that. That is a book by Hotu Bao. And of course, you can also look at the one by Duda. And there's another one here by, this one deals with multimedia, I think, or did I give you the one for multimedia? Yeah, this one, yeah. Practical machine learning tools. Well, some of these are not very useful books, but anyways, okay. But read the first ones I've given you. There's also another one here, using Oracle Data Miner. I don't know Oracle. But if you're using Oracle Data Miner, this would be for you. I don't know if it's showing or not on my small screen. It's not showing here. Yeah, here it is. So this one, they were using 11G. Now it must be gone a little bit far. And again, it goes through the same process, if you remember. Problem definition and business goals. Just have a look at it. It will give you a different perspective. Data acquisition and preparation, building and evaluation of models, deployment. Then they have given scenarios here. Now there's a practical project here. There's a practical project here. Create a data miner project. Identifying SQL developer and data miner interface components. So if you're having those tools, you can use that. So I'm just flipping through so that you know what's in our notes. Yeah, so but please go ahead and read all this. Now let's just finish it on our notes. I hope we have not deviated too much. If you have no problem, we can still. What's happening here now? All right. Okay. So we can flip through the rest of the notes very quickly. They're not very complicated. Here, I'll just show you the examples of discovering new market segments. And this one, the example I'm using here is clustering, cluster analysis or instant-based learning, or even neural network. So here is about clustering. The next one is prediction. Through, for example, forecasting of gross sales. So there's a graph there you can see. There's a graph. Are you able to see my slides?
Yes.
Very good. Yeah, so there's a graph there that is showing you how you can use regression, for example, to do this kind of prediction. Or if it is a classification, then you can even use neural networks. You can also use genetic algorithms, decision trees, SVMs, and so on. The third one there is on using description or rules. You can go to the data and you can discover such kind of a rule. If age is greater than 35 and income is less than 35,000, then blah, blah, blah. The data mining system follows exactly the same way as machine learning. Why? Because you get your data set here, you divide it into two. Okay? So the first set is called what? The training set, Cindy. The training set. The second one is the evaluation set. The one in red is a totally brand new data that you can use to be able to evaluate your thing. So here, you take the data, break it into two, training and testing set. Then you use a different unknown set. That's the second ellipse there. You see there's a big circle which has got two ellipses. So the first ellipse is the one that has been sliced into training and testing. Then the third one, the second ellipse inside the circle, it has previously not been used within the machine. So it is unknown to the machine. But that could even be a totally new different set. So use it to evaluate, to tell the percentage. Now, once you're happy with the evaluation score, now you can have a farm model. And you can now use the red data set, which is previously unknown. And you can get the prediction you want, or a model that can predict. Here is a quick example. I think this one is a very obvious one. You take data on banking data with the serial number there, the gender, the age, the marital status, the income, and so on. But the decision we want to make is whether we give a loan or not. So you can see there's in red. Those are the labels. So these are label data. Now the one on the right with the question marks is the unseen data, which we want to predict. Yeah, so you can evaluate the model and then you apply there. So I've skipped it because it's part of machine learning that you've learned. Now, this is maybe what you've not seen before, the roles in KDD, but they're also not difficult because you can see there are three main players. There's the domain expert, who is actually the business guy, the guy who is knowing that domain or that business. Then there's the mining specialist, who is now you, and there's the data administrator, who might be somebody else, or it might as well be also you. So the domain expert, you really do the business analysis question with him. This is raising the business question. Huh? The mining specialist works with the domain expert to determine the business analysis. You determine the question. Then you work with the data administrator to select the data. Then you gather it, you analyze it, of course. You analyze what you need, you gather it, and then now the mining specialist now is the one who will now start preparing it, the things we've just seen a few minutes ago. Then you apply data mining, you get the results. Now within the results, interpretation, you need to interpret it together with the domain expert. And then the domain experts go and apply it alone. The domain experts, they go and see whether maybe the profits have been increased, the losses have been minimized, satisfaction levels have been enhanced. So they go and work on it. And then the three of you, that is the domain expert, the mining specialist, and the domain administrator, rather the data administrator, they get the business feedback, whether the business goal has been achieved. If it has not been achieved, you go back and analyze from the business question. The cycle, follows the same thing we've been talking about, but you again start by identifying the business. Identify business opportunities. Again, this is a business question. You employ data mining to gain the knowledge. You deploy the knowledge, and then you evaluate its effectiveness. Then the difficulties that you'll encounter. Of course, there are things like noisy data. Now you know how to deal with the noisy data. Eh? You remember noisy data, how you handle it? Yeah, use that trimming method that I've just shown you on transformation of data. Skew distributions. Again, you dig from your statistics, you see how you can make it normal distribution from a skew distribution. Missing values, you know how to deal with that now. Scalability, you know how to deal with that. High dimensionality. Bias in data. So you can try to reduce the biasness. Then finally, you've really started realizing that this method is highly human-centered. Because you can see at all stages, it's dealing with a human being to be able to, for example, the patterns. You have to do it together with a domain expert, and it has to be manual. All right. And data mining should be interactive. So it's a highly human-centered data mining process. Now, the software tools that you may want to use are things like SAS. This one you might want to buy. It's another called Weka. This was by Australian guys. SPSS, DB Miner, IBM, Intelligent Miner, Ghost Miner. But then there's some tool that I'll be introducing tomorrow. So make sure you don't miss tomorrow's class. And if you can, in advance, please download the data, what do you call it? Orange. Stay in your notes. In the assignment that I gave you, I have required you to use it. So you can download it so that tomorrow we don't waste too much time. That is Orange, and also Kname. Now, on the ethical issues, we're just finishing now. On the ethical issues, you must use your data in an ethical manner, whereby you must filter out all personal information. You don't profile people. You don't sell data. So these are ethical issues. And then you also have to know how to use sensitive information. Like when you start asking people, kabila yako ni gani? You know, people don't like kabila yako, or what's your race in America. Some other guys are also being offended when you ask them, what's your gender? They don't want to say I'm a female or I'm a male. They just some. Now, the methodology, I said you can use waterfall, but the best method here to use is CRISP-DM, cross-industry cross-reference industry standard. And it follows the same process we've been doing. You understand the business. So business understanding. Then you understand your data. You prepare your data. You model it, you evaluate it, you deploy. Same process. And that seems to be the end, or what? Yeah, that seems to be the end of our class. You can use those resources there. Yeah, that's the end. So I don't know whether there are questions today, or we've gone past by about 7 minutes, but that's okay. Please, class reps, make sure you fill in the register. Please make sure you fill in the register and make it up to date. For you guys, help the class rep to know if they can't remember whether you're there or not. I know there's a tool that I was trying to see whether I can work with it, the one for extracting automatically the online classes. But you try your best. Okay, is there a question?
Yes, excuse me, Dr. Are we meeting online or physically tomorrow?
Tomorrow is a physical, because we have to go to the lab.
Okay.
I've even seen how to download so that you come prepared.
Yes.
Yeah, but I think there is an assignment that we didn't do because we didn't meet last week practically. We were supposed to have met for OLAP. Not OLAP. Is it OLAP? Yeah, OLAP and visualization. So you might want to go back there a little bit before you go to the mining. But that will be part of our business, the three of them. All right. And the best way is that you go to the practical assignment I've given you, start